Assalamualaikum and good day. Okay, welcome to this Triple E 2146 first class, first e-learning class. Okay, all right. Okay, actually this is my third take for this video. Hi, so I have doing this again and again. So never mind. I'll be repeating. This is the challenge of doing this e-learning. Okay. Alright, so first thing, we need to revise about our BJT, our bipolar junction transistor, before we are able to analyze the amplifier using this BJT. Alright, so I want to revise the operating regions for the BJT. Okay, so first I want you to remember back, this is the symbol of the BJT. So we have collector here, base and also emitter. Alright, so this is physically how this BJT is arranged, okay? Where we have N-type dope material here, P-type, and then this is an N-type. That's why we call it NPN BJT, NPN BJT. And BJT is also said that it is a device that has two back-to-back diode. Okay, two back-to-back means back-to-back. When you see back-to-back, this is like, can you see this? The arrow here. This is the diode, the first diode. This is the second diode, back-to-back diode. Why? Because remember diode, how it is how the arrangement of a diode is between P and N, right? Okay, and then P to N is forward diode. The direction from P to N is called forward diode, forward bias diode. And then there's another one P to N here, forward bias. So it's a back-to-back diode. Okay, where this is your collector, this is your base, and this is your emitter. So you can refer to slide number number 7, in your for your slide number 7. Okay, on BJT operating region here. So now we want to look what happened, okay, if we have the base emitter junction, base emitter junction, base to emitter junction, the diode is forward bias, and also base to collector, reverse bias. What is the name of the region? It is called forward active region. How am I going to write this? Forward active. Okay. And then what happened if we have base emitter junction? Okay. Forward bias. This is forward bias. We will say this is a saturation region. The BJT is in the, sorry, no need to write region anymore. Saturation region. What if the base emitter junction is reverse bias and reverse bias? So it is said that the BJT will be in the cut-off region. Okay, and if the base emitter junction is reverse bias and base collector junction is forward bias, then it is called inverse. The BJT is in the inverse region. Okay, so you can look the slides, the next slide number 8. Okay, so we can look at the ICVCE characteristic graph. So you will see something like this. This is I. What is IC? Collector current. And then we say, and then we have VCE. Okay, this is characteristic. IV characteristic. I is for current. This is IC. V for CE. This is called IV characteristic. The term, if you look at the textbook, this is what it means. IV characteristic of BJT. what does it mean, characteristic of BJT? Basically, how this transistor here, when we change the current I and voltage VCE here, collector emitter voltage here, how it will behave, okay? All right, so the graph will look like this, okay? When we have different IB, okay, this is actually same. This is at IB1. Okay, when we have IB1, we will have IC1. When we have IB2, we will have saturation IC2 here. When we have IB3, we have IC3. When we have IB4, we have IC4. Okay, all right. Okay, when we also have when our current is 0, this is also 0. When we change the VCE, the IC is still 0. Okay, where is the cutoff region? Okay, this is cutoff region. Okay, this one. And then this is saturation region. And then the rest here is where we have this one is forward active. You can refer slide number 8. Forward active region. Okay. Why we need to learn this? Okay, because when the BJT is in the forward active region, this BJT, okay, is behaving like an amplifier. Okay, amplifier. Okay, if we want to make this BJT works as a switch, okay, where I cannot remember, I'm not sure which subjects you learn about switching. There is like even power electronics. If you have taken power electronics, we have that. Okay, so the transistor will work between cut-off and saturation region for switch. Saturation when the switch is on, cut-off when the switch is off. Okay, all right. Okay, so how are we going to make this transistor here, okay, to be at region where we want? How? Okay, this is why we learn DC biasing. Okay, you can look at slides starting from slide number 10. Okay, I will pause here, hold on.